Welcome to Algebra 2, Lesson 1.6, Solving Compound and Absolute Value Inequalities. Before we start, you need to know the definition of two words, really. Pretty basic words. The first word that we're going to define as in define for math is and. And is going to mean what is in common. And we'll talk about what that implies in a little bit. So and is what is in common, or either could be true. We did a small portion of this in Algebra 1, and so we'll dig a little bit deeper. The problems will be a little harder than we did in Algebra 1, but you did do some of this, so a little bit of it should be familiar with you. And when we talk about and we say what's in common, you're only going to be shading on the number line what is in common with the two problems or the two answers. Or you could either one of them could happen. So you shade both answers. So let's get into our first problem, and we're going to do the first two problems that we're going to do are and problems. And the first one will say negative 12 is less than or equal to 4x plus 8 is less than or equal to 32. So this is the first time you've probably seen a problem that's in this form, where it's like two problems in one. And really, you can act like it's two problems. You can rewrite this as negative 12 is less than or equal to 4x plus 8 as one of your problems. And then write the word and 4x plus 8 is less than or equal to 32 and solve it like that. As long as you have the word and, you could do that. Or you could solve it as just one problem. So again, you want your variable to stay in between the two symbols. You want the variable, in this case x, to be in the middle. And so we want to solve that for x. So we're going to get rid of the 8. So we would subtract 8. If we do it to the middle, we have to do it to both ends there. So since they're really two different problems, you have to do it to each side to make sure that the problem stays balanced. So we have negative 20 is less than or equal to 4x, which is less than or equal to 24. Then you want to get the x by itself, and they're multiplying by 4, so we're going to divide by 4. So we divide negative 20 by 4, and we get negative 5 is less than or equal to x, which is less than or equal to 6. Now remember, I did not have to switch my sign here because I didn't divide all of the sides by a negative. If all of them had been divided by a negative, I would have flipped my sign. But in this case, it was just the numerator of this one side. So then you're going to graph this, because this tells me, and what I want you to do here when you have multiple numbers is you're going to put negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Okay, and you can make it go on a little bit farther. You can, 7, negative 6 on this side. And so you have to look at each part kind of individually at first. This says negative 5 is less than or equal to x, which we know that would be a closed circle. On this one, also closed circle. Remember, it's an and problem, so we can only solve what's in common. So it says negative 5 is less than or equal to x, or if you kind of switch that around, x has to be greater than or equal to negative 5. That means you would be shading that way. Then this one says x is less than or equal to 6. So our variable has to be greater than negative 5, but less than 6. So what's in common with that is this middle part here. This is our and statement. The middle between the two numbers is in common in this case. Okay, so let's go to problem number 2. Number 2 says negative 5 is greater than or equal to 3z minus 2, which is greater than negative 14. Again, you want your variable in the middle by itself, so we're going to get rid of the 2. So we'll do that by adding 2 to both sides. So we get negative 3 is greater than or equal to 3z, which is greater than negative 12. Again, we'll divide by 3. We get negative 1 is greater than or equal to z, which is greater than negative 4. So I'll do my number line here. We got, may start a little lower. I'm going to start with negative 5. So negative 4, negative 3, negative 2, negative 1, and 0. So if I look at this, negative 1 is going to have a closed circle on it. Negative 4 will have an open circle. This says that negative 1 is greater than or equal to z, or if you switch it around, z is less than or equal to negative 1, which means we'll be shading that way. And now it's not always shaded in the middle, but most of the time it is for the and statements, but not always. Z is greater than negative 4, so we'd be shading that way. This is the part that's in common with the two, the middle part. Okay, so let's go to OR statements now. If I do an OR statement, they are actually set up as two different problems. So we have k plus 6 is less than negative 4, or 3k is greater than or equal to 14. So we subtract 6. We're going to solve each of them individually, so we'll subtract 6. So k is less than negative 10, or we'll divide by 3 here. K is greater than or equal to, and that doesn't simplify down, so we'll leave it as 14 over 3, because I would prefer the exact answer than a decimal answer, because decimals are not exact at all. Especially on this one, it says 4.666666, so we're looking at 4 2/3 here. So if we do our number line, we have the negative 10 down here, and we have 14 over 3, which I said was 4 2/3, so it would be on this end of the number line, so we would say 14 over 3. And look at them individually for their circle. K is less than negative 10, so open circle. K is greater than or equal to 14 over 3, closed circle. And you graph them individually. If it says our variable is less than negative 10, well, it could be this answer. So our answer to this problem could be less than negative 10, or it is greater than or equal to 14 over 3. So our answer could be negative 11. It could be 5. It could actually be 14 over 3. It can't be anything in the middle here, and it cannot be negative 10 because it's just less than negative 10, not negative 10 itself. Let's do another one like that. G minus 6 is greater than negative 11, or 2g plus 4 is less than negative 15. So what I would like you to do right now is I'd like you to pause the video, solve this problem, and then push play and make sure you got the answer right. Okay, so hopefully you have paused the video and you're on your way back to check your work here. So we solve this one by adding 6. And so we say g is greater than negative 5. Or, on this one, you subtracted the 4. It's a two-step problem. Divide by 2. G is less than negative 19 over 2. So let's go ahead and make our number line. And 19 over 2 is, or negative 19 over 2 is negative 9.5. So if we're going to put them on the number line, and make sure you put them on the number line correctly, like the smaller number goes on the left-hand side, the bigger number goes on the right-hand side. So negative 19 over 2 would go on the left-hand side. Negative 5 would be on the right-hand side. The negative 5 has an open circle, and so does the negative 19 over 2. It says our answer is greater than negative 5, or it's less than negative 19 over 2.